Hello everyone, this is Pranav Bansal, and in this video, I'm going to be talking about my journey of how I trained a machine learning model that can recognize Indian Sign Language from a video. So I made it as my capstone final year project, and in the starting, I had to do a lot of research. I researched about different approaches that researchers have used and published papers for recognizing different sign languages across the world. Most of the research work that was done, I found that it was done for the recognition of American Sign Language. And I found three types of approaches that they had used. The first approach included the use of specific hardware such as hand gloves or motion sensors to detect accurate positions of the hands. The second approach that I found was based on deep learning models and skin masking. So they gave skin masked images as input to deep learning models and then extracted some features from them and then recognized the sign. So now let me talk about the limitations that I found with these two approaches. So the first approach that involves the use of hardwares is not good, although it's pretty accurate and it can recognize almost any sign, but the hardware that it requires are not easily available to everyone, and also they are expensive. And sometimes these hardware require a specific environment to be maintained to be used. Basically, this approach can't help everyone. Now let me talk about the limitations of the second approach. So second approach involves the use of deep learning models and skin masked images. Skin masked images are basically images where the area of the region of this image where the hand is present. Suppose in this frame you're seeing my hand, so this is the area of the frame where the my hand is present. So the image is altered by modifying these pixels in this region with a specific color such as white, and the rest of the pixels in the image are made black. So this way skin masked images are prepared, and then these images are given as input to a deep learning model, and then that model classifies that particular sign into different categories. Now, limitation with this approach is that it can work really well for a small data set that includes limited number of signs, but as they keep including more signs in the data set, the approach will start to fail because there are a lot of signs with almost similar hand movements, and so there are not enough features to be extracted from skin masked images. Therefore, this approach is not good, and also deep learning models oftentimes require the use of high amount of resources, so they might not be able to perform really well on normal devices. Now, the third approach that I found and I think is the best is through the recognition of key points from the body. So they basically used pose estimation models that recognize a set of key points from the body. So I'm sure you must have heard of PoseNet or open pose models. So what these models do is they recognize a set of key points from different parts of the body. So if I talk about hand, these models can recognize around 21 key points of the hand, and by analyzing the positions and movement of these key points, that the features can be prepared and data can be generated, and that can be given as input to some machine learning model that can classify these signs corresponding to different languages. Till date, what has been the problem is these models cannot run fast in real time. The FPS of PoseNet is around 0.1 to 0.3 FPS, so that's not a very good rate. That's why these cannot be used effectively in real time, although they had great accuracy, but still they cannot be used in real time. So I thought that I would start working on this approach. Then I found out about Mediapipe, which is a lightweight framework released by Google, and it can detect those specific key points in almost no time, in real time, and it works really smoothly. So I thought that now using this approach would be really great. And also there was almost very less research work done for the recognition of Indian Sign Language from videos. So I thought, yeah, that can be a great way to start this project.
Okay.
So now I'll explain you guys about how I made the project. So before training any machine learning model, we require data, and the data set for Indian Sign Language is not publicly available anywhere. No one has actually prepared and uploaded it on the internet. Therefore, I had to prepare my own data set. Just to start with the project, I created the data set for different alphabets and different digits because I didn't know how much time it would actually take for the machine learning model to be trained on this particular data set. So that's why I kept the scale of my project limited to recognize alphabets and digits from videos. Therefore, I prepared a data sets where I recorded myself mimicking these different signs for alphanumeric uh, symbols. So I'll just show you the data set at once. So I captured my videos mimicking these signs, and then I extracted all the frames from those videos using Python. So I'll just quickly show you some of the frames. So this is the sign for the symbol 0, and I recorded myself by doing the sign from both the hands, so that the final machine learning model can work for both the hands. So here you can see I sequentially extracted all the frames. So in this manner I actually recorded and created dataset for all the letters from A to Z that are 26, and then digits from 0 to 9. So that's how I have a total of 36 different classes of the sign. I also had to check and discard any unuseful frames where like my hand is not in the frame and it's not in a good position. So I discarded those frames by obviously by manually reviewing and all that stuff. I used Google's Mediapipe. So let me just quickly show you how the Mediapipe works. So basically, this is a web page there where they have provided or integrated Mediapipe hands library, and you can go online and check it. Um, so it kind of gives you an overview of the different graphs and subgraphs they are using and how they are using it, and you can just run it and see how effectively it works in real time. So I have run it. Okay, so see, as soon as I take my hand in front of the screen, it can accurately detect all the 27 key points in the hand, and it can also detect which hand it is. So currently they have configured it for recognizing on only one hand, but it can be easily changed for recognizing multiple hands at once, and it would take the same amount of time. So see, no matter how fast or how quickly and in what direction I change my hand, it can accurately detect all those key points. If it's a left hand, then it would work fine. So yeah, that's a demo of MediaPipe. Now I used this MediaPipe library, which they have provided as Python package. All right. Now that we have a data set of different images prepared, it's time to process those images and process those images using MediaPipe and extract all the required information. So when I gave those images input to the MediaPipe, so it automatically discarded all the images where it could not detect all the key points, and it kept all the images where the key points were detected accurately. So this is the sign for the digit 0, and you can see the MediaPipe library has recognized all the key points very effectively for representing that particular sign. Now this image is not the data set, but for the data set I have actually stored the normalized positions of these coordinates. So I'll just show you what I'm talking about. So basically this CSV file is my data set. In this CSV file I have 63 or 64 different columns. I'll explain them briefly. So yeah, so we have 21 points, right? So for 21 points we have x and y coordinates, so that would be total 42 coordinates. So I have saved the positions of those coordinates, and the position of the zeroth coordinates of the zeroth points are 0 because I have used origin shift function. So basically I have found the new coordinates of every point by shifting the origin to the zeroth point. So this helps in generalizing the data more, and and now the position of hand anywhere in the frame would not matter much. So these are basically the coordinates of the point when the origin is shifted to the 0th point, and also these coordinates are normalized automatically by the Mediapipe by dividing the x coordinate by the width of the frame and y coordinate by height of the frame. So in this manner, we have these 42 different columns for x and y coordinates of these points. Next, for increasing the feature space, I have also included the Euclidean distance between the 0th key point from every other key point. So that gives me 20 other columns. Um, and then I have one column for the handed nets, whether it's a left hand or right hand, because that might also play some part in recognizing sign. Then obviously we have the last column label, which tells us which sign these coordinates correspond to. And then I have location of the frame. So I save this location so that I can delete those rows where the coordinates have not been successfully identified. So yeah, that's my data set, and I have this data set for all the 36 different signs. Now I loaded this data set to be given for training to the machine learning model. So you can see here I have loaded this data set, and you can see the information related to different columns. I have 63 different columns, um, and now before giving input to the machine learning model, there is one column handedness, which is actually in string format. It's right or left, but uh, machine learning model only works on integer or float values. So I had to encode that column into 0 1. So basically, uh, if the value was right, I change it to 1, and if it was left, I change it to 0. And that's how the column has now been encoded, and the data frame can now be given as input to the machine learning model. So now we need to have the data set X and the label corresponding to it. So I have the dataset training dataset and the training labels. So with the help of train test split, I split it into training and testing dataset. So 70% of the data I have kept for training and 30% for testing, because we have a huge dataset, so it doesn't matter if it's 25 or 30. Um, Next, I trained a logistic regression model, and the accuracy that I got for it was around 93%. These are some statistics. Yeah, there we go. The accuracy that I received for logistic regression was 93%. So I trained decision tree classifier, and I got an accuracy of 96%. So if you see the confusion matrix of logistic regression, then you can see that these are some of the signs which have not been accurately recognized. So it has some errors. If you see the confusion matrix for decision tree classifier, then you can still see these are some of the signs where they have not been properly categorized. So next I trained a random forest classifier, and it surprisingly gave me an accuracy of 98%. Um, and if you see its confusion matrix, then you can hardly see any sign which has not been categorized properly. So now because my machine learning model has already been trained with high accuracy, I just saved it, and but once the machine learning model is ready, you can directly use it in real time. So I'll just also show you my approach of how I'm using it in real time. Let me just open the workflow. All right, so I hope it's visible. See, what happens is we first have the input frame from the video, and which is given as input to the Mediapipe hands library. So Mediapipe hands actually consists of two machine learning models in the pipeline. The first is a palm detection model that detects the position of the palm or hand in the frame, and then that cropped region corresponding to it, corresponding to the hand, is given as input to the hand landmark detection model. So because it's the cropped region, so it becomes easier for the landmark detection model to detect all the key points accurately. That hand landmark detection model give the that detected key points as output, and it also tells whether it's the right or the left hand. Now when I have the key points and all this information, so basically this was all my feature space, right? We had all the x and y coordinates, then we also had the distances. So see, as you can see here, now that we have the key points, uh, uh, it is those key points are given as input to two different functions. The first function is for origin transformation, as I told you about, that I had to normalize and generalize those coordinates. So the origin is shifted to the 0th point, and new coordinates for every point are calculated. And similarly, distances are also calculated between certain points. So and now we have the coordinates, new coordinates, and the Euclidean distance, and also the handedness, which was written by a landmark detection model. So this consists of all the feature space, 42 coordinates and 20 distances, and then one column for the handedness. This can be now given as input to the machine learning model, because it was trained on this feature space. So when this would be given as input to the machine learning model, it will easily classify those signs. So as you can see, this is the sign for V alphabets, and that's effectively categorized it. So that's the whole workflow of the machine learning model, of my the code in runtime. Um, so yeah, that was all of my project. Thank you for watching.